Like I said in my first welding video, I taught myself how to weld plastic after I could only find videos on YouTube that don't really count as welding. I failed to mention that I also took a 2-year metals welding track in high school, and that knowledge is being passed through to my plastic welding. After falling down a rabbit hole of watching other people's videos on fusing plastic in very creative ways, I decided to make a follow-up video. Come with me as we go through the specifics of a few different welding scenarios. I have 3 different weld scenarios that we will be going over in this video: the T, lap, and vertical welds. The butt weld is the weld that I did in my first welding video. Go ahead and check that out if you haven't already. This weld scenario is the most basic, consisting of 2 parallel plates coming together in the same plane. A T-weld is 2 plates coming together perpendicular to each other, typically making a T shape. However, it could look more like an L. A lap weld is when 2 parallel plates overlap each other and the edges that make contact are welded together. A vertical weld can be any of the welds I mentioned, but you can't orient the parts so that the weld runs parallel to the weld table. This way, you end up having gravity working against you. An overhead weld is just as it sounds. This is any weld that needs to be done overhead. In this scenario, gravity is working directly against you. I have the most fond memories of molten metal going down the back of my shirt, a place where explicitives were forgiven. I won't be attempting overhead plastic welding in this video. I don't really have a great way of achieving that with available tools. I have mostly used butt welds in my projects, so we'll be learning together on the other welds. I do have a PlayStation controller case where I welded the hinges on. Those are pretty close to lap welds, but let's try a textbook lap weld with the weld coupons. It's always important to set up your weld area to be as static as possible. Any amount of movement can cause the weld to be trashed. Like you have seen in my last video, I am fortunate to have a fixture plate that could help hold everything in place. A typical welder in a shop could have a welding table, which is like a fixture plate, but on a larger scale. There are a variety of accessories that can be bought to help you hold your workpiece. But it is also fairly easy to make your own if needed due to the regular and consistent spacing of the holes. If you don't have a great way to fix your parts that you are welding, you can try using your soldering iron to tack the 2 pieces together just enough so that they don't move relative to each other. Just like in the butt weld, we're going to preheat and pre-place the filler material so that it sticks until we get to welding. Now we can start welding. Like the butt weld, we are going to use a helical motion while welding. However, in this case we have to work against gravity and push the material upwards at the same time. So we're first digging into the bottom plate, then pushing up into the top plate, then back down again. We can continue this motion until the end of the weld. Remember, most of your heat comes from the heat gun. Ideally, the weld would create a smooth chamfer from the top of the plate down to the bottom plate at about 45-degree angle. This may require multiple passes to achieve, the first weld being called the root weld, the subsequent welds being called the filler welds to create the chamfer. And that's it. The weld does not look great, but I think it will hold. Now I'm going to flip the plates over and do the other side. You may also want to do the sides as well if possible, but I will not be more confident in if that is necessary until after I get around to load testing. I am saving all of these completed welds for a future video of load testing these welds, but that may be a few weeks away as I prepare for it. Let's move on to the T-weld now. In order to set up this T-weld, I got some 3/16 inch thick 2x2 aluminum angle, cut it to length, and drilled some holes in it to match up with the fixture plate. The angle plates that I could find for sale were quite expensive in comparison, and the thicknesses were quite overkill for this scenario. The process for the T-weld is effectively identical to the lap weld, but you have some more room for activities. However, since I didn't show a filler weld in the lap weld process, I will show you one here. While filling, the goal is to really just thoroughly incorporate the filler material onto and into the other welds in the part. The primary goal is to make a nice chamfer, and it may take a few passes. If you are welding metals out in industry, the sizing of the chamfer or fillet would be determined by an engineer based on the expected stresses on that joint. Alright, that's the T-weld complete. I ended up welding another T-weld off camera because it is quite difficult to do this while straddling a tripod. Of course, that one ended up being much better. Let's move on to the vertical weld. I decided that it would be easiest to vertically weld the other side of the coupons that I T-welded. This way I don't have to make another angle piece to fix to. Our biggest challenge here is gravity. While welding vertically, we are going to have to angle the soldering iron upwards, and possibly need to move it back to push filler material back up again. I didn't have much of an issue getting vertical welds down when welding steel and aluminum, but we'll see how this goes. PETG doesn't seem to get super fluid at 260 degrees Celsius, so this may not be much different from a horizontal weld. I managed to get the filler material to stay in place by melting the filament over the top of the part first, creating a hook for the filament to hang from. The first try actually went pretty well. The plastic is very sticky, so it didn't flow down the joint uncontrollably. Well, here are the results of these attempts. None of the welds that I did in this video ended up looking amazing, but they seem to be structurally sound. I'm excited to test them one day. Maybe one excuse is that I had to work around the cameras in order to get good views, but I will definitely get more practice with future projects. I hope you all found this helpful and interesting. I sure had fun making this. Thank you for watching. Please consider liking, commenting, and subscribing. This isn't my day job, so I just post videos whenever I can. Thanks for sticking around.